I just did it. If you got a sticker, it means they were right. If not, I try to like make a comment on it. But obviously, if you were like working a little bit behind everybody else, I may not have gotten yours. Don't stress out. Doesn't mean it's wrong. Use this to check to make sure it's right. So the first one, your amplitude is 2 because your A is 2, your amplitude is 2, your B is 2, your period is 2 pi over 2, which becomes pi. The period times a fourth, a half, and 3/4 gives you the first point would be 0, then pi over 4, then pi over 2, then 3 pi over 4, and then the period being the last one. Amplitude is 2, this is cosine, so we start at the amplitude, you go down, down, up, up. Good job, Oliver. Second one, this is a negative sign. So the negative on the front flips your sign upside down, meaning you're going to start at 0, go down from there. The A is 3, that's your amplitude. The B is 2 pi, which makes your period 1. 1 times a fourth, a half, and 3/4 means your key points are at 0, 1/4, 1/2, 3/4, and 1. And again, we start at 0. We go down to -3. We come back up to 0, up to +3, back down to 0. Good job, Amber. Then we had sine x minus pi, and this is your phase shift one. So everything else was 1. I promise you it won't be this easy test-wise. You're going to get multiple kinds of changes. So an amplitude change, a period change, a phase shift. You will for sure at least have one phase shift change question, so just keep that in mind. And then obviously the vertical shift if we were to shift these up or down. So here we've got a shift to the right, pi. I took all my key points, which were 0, pi over 2, pi, 3 pi over 2, and 2 pi, and added pi to them, making the first key point pi, then 3 pi over 2, 2 pi, 5 pi over 2, and 3 pi. This was sine, so some of you graphed cosine. Be careful, make sure you're paying attention to the curve. You start at 0, go up to the amplitude, which is 1, come down, down, and up. Good job, Angelina. And the last one, negative cosine x plus pi over 2. So the negative flips it upside down. Cosine, some of you graphed sine, so again, be careful. And the phase shift is a negative pi over 2. So we're shifting everything to the left, pi over 2. This is cosine, and it was negative, so we start at the -2 and then work our way back up. The only thing you didn't see in this warm-up was a vertical shift, so just be prepared that if you saw something like a +1 at the end, we would take all of our coordinate points and shift them up 1 unit, and my curve would look a little bit like this. Be careful on the ends of your cosine curves. Make sure they're kind of rounded, because today we're going to drop them, either pull them up or drop them down to continue that curve to make your secant graph, okay? Good job, Michelle. So I just put the link to the old calc chat because this is what this is from. Right on the assignment, the odds were on there. So this is 81 from it. When you graph it, it looks like it's what on the right. And B says find the time for 1 full respiratory cycle. That's 1 period. So you just had to find your period, which is 2 pi over B. B is pi over 3. So 2 pi over 3 becomes 6, and it's in seconds. So if it's 6 seconds to do 1 full cycle, and then C says find the number of cycles in a minute. If we're going from seconds to minutes, I'd have to do the 60 seconds divided by the 6, and it's 10 cycles per minute. And then the model is for a person at rest. How might the model change for a person who's exercising? Obviously, it should be like faster, right? So it's actually a horizontal shrink, okay? Or you could say, you know, the curve happens faster, something like that. All right, so speaking of 4, 6, these are graphs of other trig functions. So we are going to do tangent, cotangent, secant, and cosecant. Good news is if you know secant and if you know sine and cosine, you know secant and cosecant. If you, yeah. You can just exit out of it. I have it'll save it, yeah. But send it to Notability so you have it for reference for review, right? So remember, you want to send your class pick to Notability because once I close it out, like I'm not going to do that right now, but once I close it out, it gets deleted. So you want to send it to Notability. Okay, so we start with tangent. Our tangent curve looks completely different from sine and cosine, from secant and cosecant. The tangent and cotangent both have vertical asymptotes, and then they have curves that look like cubic functions in between. So think about why we have asymptotes. If you go around your unit circle, remember tangent is undefined at the top and at the bottom. So it's undefined at pi over 2 and those coterminal angles, and 3 pi over 2 and those coterminal angles. Which means undefined results in the asymptote, okay? So the way we solve tangent is very different from what we do the other ones. I'll tell you that, I'll go through the steps in a minute. But this is what a repeated cycle of tangent looks like. When you're graphing all of these curves in this section, I need 4 asymptotes and 3 curves. So depending on where the asymptotes are, you are going to give me 4 asymptotes. I'm going to teach you how to get them. And you are going to give me 3 curves. And that is true for tangent, cotangent, secant, and cosecant. And again, note that tangent is like a cubic function. It goes up to the right and down to the left. Okay, the vertical asymptotes on my parent function are odd multiples of pi over 2, but I'm going to teach you how to get them because they're going to shift. The range would be all real numbers, which is why the arrows point up and down. There's no limit on the tangent like there is the sine and cosine. It can't be bigger than 1 there. Okay. Domain, obviously all real numbers except for where those asymptotes are. And the period changes for tangent. The period for sine and cosine were 2 pi. The period for tangent is pi. But again, I'm going to teach you all this stuff. So this is what we do first. Okay. We are going to take whatever's next to the tangent, which is our bx minus c. And I'm actually, instead of doing this, we're going to go straight to here. We're going to set bx minus c equal to negative pi over 2 and equal to positive pi over 2. We're going to solve for x, and those are our middle 2 asymptotes. We're going to find a the way we always do. So the amplitude this time is a little bit different. We're going to find b the way we always do. And then the period is pi over b, not 2 pi over b.
That actually makes sense because like tangent is sine over cosine, and period for that is 2 pi and 2 pi over 2.
Whatever you just did there worked for you, and keep it. Okay, I was going to say, I'm not going to tell him he's wrong, because if it makes sense for you, go for it. But just know it's because tangent repeats every half circle, right? Every half circle, the tangent is exactly the same value. It's different with sine and cosine. Just know that period for tangent and cotangent are going to be pi over b. So then once I get that, I'm going to take this pair that I got from here, these asymptotes. I'm going to subtract the period from the one on the left, and I'm going to add the period to the one on the right. And there you will have your 4 asymptotes. Then we're going to find our halfway point between each asymptote, and that's going to be your 0.
How did you find the opposite?
Well, the middle 2, you get negative pi over 2, positive pi over 2. Then you're going to subtract the period from the one on the left, and you're going to add the period to the one on the right, and that's your 4.
Is pi over b, right?
Period is pi over b. Yep. Yeah. And then you're going to find the halfway point in between, so midway point in between the asymptotes, and that's your x-intercept, or your 0. And then we're going to find the quarter point and the 3/4 point, and that's where you hit a and negative a. So I will kind of simplify these steps as we work through them. I know that's a lot of words, but I want to show you what it looks like, and then we'll kind of like write it out. All right, so it says graph the following equation, y equals tangent of 2a. So start the way we have been starting. What's our a? 1, okay? Which is the amplitude, but it works very differently with tangent. We just need to know it's 1, okay? Yeah. B is what? Still in between the trig function and the x, right? 2. So the period is pi over b this time, or pi over 2. We're going to need that in a minute. Next thing we do is take our bx minus c, what is ever next to the tangent, which in this case is 2x. We're going to set it equal to negative pi over 2 and positive pi over 2, because that is where tangent is originally undefined. Negative pi over 2, positive pi over 2. Now we're going to solve for x. So we're going to divide both sides by 2, which is the same as multiply by a half. X equals negative pi over 4. Multiply by a half. X equals positive pi over 4. These are our middle 2 asymptotes. Actually, let me circle the whole thing because it's an equation. So these are our middle two asymptotes. If you do it in the correct order, if you put negative pi over 2 on the left and positive pi over 2 on the right, you'll always follow this pattern. From the one on the left, we are going to subtract the period. And from the one on the right, we are going to add the period. So on the left, I'm going to take negative pi over 4, and I'm going to subtract the period, which is pi over 2. And on the one on the right, which is positive pi over 4, I'm going to add the period, which is positive pi over 2. Change my equation to have a like denominator. And I get x equals negative 3/4. There's the first asymptote as I move from left to right. On the right, this becomes 2 pi over 4, 3 pi over 4. X equals 3 pi over 4. That's the last fourth/last asymptote as I move from left to right. So I've got 2 negatives and I've got 2 positives. I'm going to make my graph have space on either side of my y-axis. I have negative 3 pi over 4, negative pi over 4, positive pi over 4, positive 3 pi over 4. These are where my asymptotes go. I could have spaced that out a little better, but you get the point. Now I got to figure out the halfway point. So either, sometimes it's easy, and you could just see it, like halfway between negative pi over 4 and positive pi over 4. Hopefully we see that one, right? This is 0. That one doesn't require much work. That's an intercept, so that's a 0. That gets a dot. Halfway between negative 3 pi over 4 and negative pi over 4 is negative 2, no, well, here, let me just show you. Negative 3 pi over 4 plus negative pi over 4. So I'm going to find the midpoint, add them together, and then divide by 2. So this is negative pi over 2. Add them together, divide by 2. Have the midpoint. Do the same thing with pi over 4 and 3 pi over 4. Add them together, and then divide by 2. That's how we find the midpoint. Now we need to figure out a quarter point and a 3/4 point. I don't need you to figure out an exact point there, okay? You'll never finish this test. I want you to eyeball where that would be. So about a quarter the way in from one asymptote to the other would be there. About 3/4 the way in would be there. So you're just splitting the difference between the asymptote and the 0, and then the 0 and the asymptote. So you want to mark a quarter and 3/4, a quarter and 3/4, just like that. Because that's where my A is going to be graphed.
This is the what?
This is where I'm going to put the A. So you're doing about a quarter, like a quarter the way in. So from here to here, a quarter. So halfway between here. And then halfway between here. You just want to mark it. You don't need to make it exact. And then my A was 1. So I'm going to put a line at 1 and a point at negative 1. A quarter the way in, I need to be at negative A. So at a quarter the way in, my point goes at negative 1. 3/4 the way in, it goes at positive 1. A quarter the way in at negative 1. 3/4 the way in at positive 1. A quarter the way in, negative 1. 3/4 the way in, positive 1. And my curve passes through those points. So 1 was find the A, right? 2, B, and then the period is pi over B. 3, set my bx minus c equal to negative pi over 2 and positive pi over 2. From the one on the left, you're going to subtract the period. From the one on the right, you're going to add the period. And those are your asymptotes. Find the quarter and the 3/4 and mark it. Actually, find the halfway point first. Find the middle. And that's your 0. Find the quarter and the 3/4. This is the negative A and this is the positive A. And then draw your curve. Tangent goes up, right, down, left. All right, we will pick up there tomorrow. Okay, obviously, if you are familiar with tangent and you want to get a head start, it's a PDF again. I'm going to open it up. But if you have no idea what we're doing, don't freak out about it. We're going to continue it tomorrow.